engineers. Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's in a way you can keep me going, refreshed, and inspired. And of course, if my videos are important to your studies, then don't forget to subscribe. And you will not miss different problems in theory of structural theory. So here we go. This problem was solved using the first method. Let's verify it by the shorter one and more direct one, the energy method. By the method of least work, or the method of least work, determine the support reaction. CI is 100,000 kilonewton meter square. Support settlements A 5 mm, B 18 mm, and C 12 mm. So here is the structure, and we will compute the net displacement at B. So 5 at A, 12 at C. So by similar triangles first, let's call this HB. That one, HB is just a portion of this triangle. So we have 5 mm along this horizontal, then HB is just the height of this portion of this triangle. Then 12 minus 5 is 7, so this is 7. So by similar triangle, HB as to 6 equals 7 as to 14. So HB is equal to 3 mm. Therefore, this total distance from support B to this yellow dashed line is 8 mm. Should the displacement at B be 8 mm, then there's no effect. The displacements will have no effect because they have proportional settlements, or as if they are just on the same horizontal plane. Now, because this is 18 mm, that means the net downward displacement at B would be 18 minus 5 minus 3, so 10 mm. So that means point or support B is below this dashed yellow curve or line, and therefore the net settlement is 10 mm for B. As I said, if the settlement mentioned at B is 8 mm, then the settlements cannot affect the results by analyzing it as if there are no settlements. Because at B, the settlement is 18 mm, so the net settlement is 10 mm. And this 10 mm is treated negative if the reaction at B is upward and the displacement is downward farther by 10 mm, so this is treated negative 0.01 meter. So let's assign that as RA, RB, and R sub C. I select RB as the redundant, so let's express RA in terms of RB by summing up moments about C equals 0, Cx is 0, readily. So RA times 14 plus RB times 8 equals 30 times 3 plus 20 times 6 times 11. So RA in terms of RB, our redundant force, is negative 4 over 7 RB plus 705 over 7. So therefore, our segments would be from A, as shown. So those are our segments. Anyway, we use our calculator because that is allowed in evaluating the integrals. So EI delta B equals EI partial of U with respect to R, which is EI 100,000 times negative 0.01, because RB is upward and the farther net settlement is downward 10 mm. So they are opposing by the principle of work. It is treated negative. So Integral 0 to 6 of RA times X, which is negative 4 over 7 RB plus 705 over 7. Do not write this as RA, but write that in terms of RB because there's only one redundant force. This is indeterminate to the first degree. Plus 705 over 7 times X minus 20 times x over 2 or 10x squared. The derivative of this moment equation with respect to RB is negative 4 over 7x. That's why you have negative 4 over 7x dx. Then in the next section, plus integral 0 to 5 of RA, again, negative 4 over 7 RB plus 705 over 7 times x times quantity, times quantity 6 plus x plus RB times x minus 20 times 6. This is 3 plus x, so 3 plus x would be the moment R. Then derivative with respect to RB is negative 4 over 7 times 6 plus x. And we have RB again here, so derivative is x dx. Then for the last segment, integral of 0 to 3 of quantity negative 4 over 7 RB plus 705 over 7 times quantity 11 plus x plus RB times quantity 5 plus x minus 30 times x minus 20 times 6 times 11 plus x. 20 times 6, 3 plus 5, so 8 plus x, and minus 30 times x. The derivative of this moment equation with respect to RB is negative 4 over 7 times 11 plus x plus 5 plus x dx. The value of the first integral, RB first, then the constant. By the way, this is negative 1000. Value of the integral here is RB and constant only. 1152 over 49 RB minus 112320 over 49. For the second integral, with respect to RB, this one, use integral of this squared, dx, 0 to 5, then the constant. So 1455 RB over 49 minus 117450 over 49. And for the last integral, you just, by experience, you just evaluate this quantity square, 0 to 3. That's the coefficient of RB, 81 over 49 RB. Then for the constants, 9315 over 49. Simplifying, negative 1000 equals combined RBs here, 384 over 7 RB, then combine the constants, negative 34155 over 7. So finally, we can now solve RB. RB is 70.716 kilonewtons. RA is equal to this, negative 4 over 7 of 70.616 plus 705 over 7. So R sub A is 60.305 kilonewtons. Then R sub C, summation CY, summation moment A is 0. So CY times 14 plus RB 70.716 times 6, then equals 20 times 6 times 3 plus 30 times 11. So CY equals 18.97 billion. So I leave the checking to you, summation versus Y. It should be more or less 0.